Assalamu alaikum student, welcome to daily physics lecture. Today's lecture is 11. So in the past few days we were discussing about Kirchhoff's law, and we were discussing about the multiple loop problems. So in the previous lecture I have given you this circuit or close to this circuit, and lot among you were asked me that this is little tough, so that you can't understand how to get the current flows. So that's why today I am discussing about this circuit. Okay, so what will be the current flows, or how will we get it? So what is the question? Calculate the current flow through each resistance. That means we have to calculate the current flow through how many resistance doesn't matter. We have to calculate the current flow through all those resistances. So now here I have given you the steps which we already discussed. These are the steps by which we can get the current flows of the circuit. And the first step is that naming points. Okay, so let's name the points. So now if you see this, there will appear some problems in your exam hall where you need not to go through step 1 because they have already completed this step 1. Look, A, B, C, D, E, F, G, S, they already did it. The points are already given, so you need not to mention it or write it. So step 1 completed. So let me find out what are the junctions. Okay, so initially at first here is this question. We know the question. Here this B, C, F and G, these 4 are junctions. Okay, so our junction is B, C, G and F. So what are the lines? Okay, lines, find out the lines. What are the lines? Junction to junction, these are known as lines. So here B, A is G, from B to G junction. B, A is G, it's a line. B, G is another line. C, F is another line. B, C, another line. G to F, another line, and C, D, E, F, this is another line. So in total we have 1, 2, 3, 4, 5, 6 lines. How many lines? 6 lines. So as the lines, we have 6 lines, which means we have 6 current flows. Okay. So what about the second option? Assume the current flows. We have to assume current flow, and we have to get the current flow at the end of the solution. But now they already given us the current flows. This is already mentioned in this step. So let's see how many current flows given. I1, I2, I3, I4. 4 current flows given, but we have 6 lines. So through B, A is G, through this line, that is the left side, they already given us the current flow, and this I1. Through B to G, that is this line, they already given the current flow through B to G, and this I2. From C to F, they already given us the current flow, I3. From B to C, they don't give us the current flow, and from G to F, they don't give us the current flow. So they didn't give us the current flow through these 2 lines. And C, D, E, F, they have given us the current flow as I4. So these 4 current flows are given already. They give us the name, they give us the direction. So you need not to get it, you need not to put these things. Okay, so this step 2 is already completed. Now, the question was calculate the current flow through resistances. Why are the resistances? So how many resistances are here? So here we have 10, 2, 6, 4. We have 4 resistors. This 10 and 2, look at this 10. This 10 and 2 ohm, these 2 are in the same line. Okay, so the current which will flow through 10 will flow through 2, right? The current which will flow through 10 will also flow through 2 ohm, right? So this I1, that means the current flow through BASG, this I1 will current flow 10 and 2. So I1 will flow through 10 and 2. Okay, through this 6 ohm, I2 will flow, which is around B and G point, around BG line. So I2 is the current flow through 6 ohm. There is no resistance in the line of I3. So we need not to get it because no current is here at the line of I3, no resistance is here, so we need not to get I3. And what about there we have another 4 ohm, and this 4 ohm is located at C, D, E, F line, and the current flow through this line is I4, so we have to get I4 because we need to get the current flow through 4 ohm. So we need to get I1, I2 and I4, these three. I1, I2 and I4, we need to get these three. Okay, so let's get it. So before we get it, so let's complete the steps. So we are done with 1 and 2 step. What about the step 3 and its default positive or negative? Previous 2 days I have told you I want to assume default direction, positive direction as clockwise. It's all about me. You can choose anti-clockwise, it's all about you. It doesn't matter. So my choice is clockwise. So all those loops I will assume positive as clockwise. So clockwise, clockwise, clockwise. Okay. So now find out, is there any line, or we have completed 3. Is there any line which is resistanceless? Now if we go through these lines, this is resistance of this C and F. Look, this line is resistanceless. So CF line is important. So as this CF line is resistanceless, so we have to assume, we have to take this CF line as common. Okay. So let's use the junction law. I will later use the junction law. I will go through the summation of E is equals to summation of IR, the last step. Why? I will tell you later. Okay, I have to get I1, I2, I4. Okay, first get I1. Okay. Oh, please remember, we have to take CF as common because CF line doesn't include any resistance. So if I take CF common and I want to get I1, so I have to take this loop, okay, from C, A, H, F, C. This loop. Because I want to get I1, that means the current flow through BA is G, and I want to take the common as BF. So BF is common, sorry, CF is common, and I want to get I1, so I should take C, A, H, F, C loop. Okay, I have taken it. Oh, there is one thing which is bothering us, and that is BG line. Okay, if I go through C, A, H, F, C, this loop, this BG line is not important. Okay, so let's erase this line, hide this line for a couple of seconds. Okay, we have it. Okay, no trace of BG line. So C, A, H, F, C loop. Use Kirchhoff's second law. Okay, okay. Left side, summation of E. Summation of E. How many cells are here? Go through the loop. We have one cell here. Oh, only one cell. We have only one cell, and this good looking cell is 10 volt. Okay, 10 volt. That's the positive side, that's the negative side. So direction of 10 volt will be upward like this, right? Towards positive, right? So this will be the direction of 10 volt. And now that clockwise default positive direction. So I'll use a clock. So there's the clockwise direction, my hand. So my hand is acting clockwise. Look at this, 10 volt. Is it acting clockwise or anti-clockwise? It is acting toward the opposite direction of my clockwise hand, right? So this 10 volt is a negative cell. We don't have any more cell, so we are done with the left side. Now, right side summation of IR. How many current and resistance? How many resistance do we have? No resistance, one resistance, two resistance, no resistance. So we have only two resistance. If we go through this 10, look, what is the current flow through 10? Through this line BAHG, the current flow is I1. So I1 will flow through 10 and I1 will also flow through 2. So 10 and 2 are both in the same line. So the current flow will be I1 through 10 and to both. So for 10, it is a 10 I1 current into resistance. So 10 I1. Let's find out whether it is a positive or negative current. I1 is moving downward. Look, through 10 I1 is moving downward. So let's go for the clockwise positive direction. That's the clockwise. Look at this clockwise direction, my hand. And the current flow direction is not acting along the direction of my clockwise hand, right? So the I1 through 10 is a negative current. What about this 2? 2I1, is it positive? No. Look, I1 is also acting through 2 and it is also acting against the clockwise, default clockwise positive direction. So this is also negative. So all are negative, very weird. Doesn't matter, we can just nullify this negative side from both in. So it's a 10 is equals to 12I1. Okay, minus 10 is equals to minus 12I1. So we can write I1 is equals to minus minus crossed. So 10 by 12 is a 5 by 6. It's a positive current. Oh, great. I1 is a positive current. So 5 by 6. Okay, I1 is the positive current. So let's get another current. Let's get I4, the current flow through 4 ohm. For this loop, we have to take CF as common because it's resistance less. C, D, E, F, C. Okay, C, D, E, F, C. Loop. We use summation of E is equals to summation of IR. That's pretty well. Left side, how many cells do we have? We have 1, 2 cells. We have 2 cells. Okay. So this 10 is acting upward. I have already said that. So now our loop is at the right side. So let's use your hand as clock. So clockwise direction positive. So now here 10 is now acting clockwise, right? For this loop 10 was acting anti-clockwise, but now for this loop 10 is acting along the direction of clock, right? So 10 is a positive cell. Now what about this 6? Okay, this is another cell. It is acting downward, right? 6 ohm is acting downward, 6 volt is acting downward, this cell. So our default positive is clockwise, and now this 6 is acting along the direction of the clock. So 6 is also positive, right? Now what are the right side? How many resistance do we have? Go through the loop. We have one resistance, 4 ohm. No. We don't have any other resistance. So only 1 4. And how many current is flowing this through 4? 4 is C, D, E, F line, and in this line the current flow is I4. So I4 is also acting through 4, right? So you have to get I4. And that's the direction of I4. So it's a 4I4 current into resistance. Okay, and let's see what is it positive or negative? Our default clockwise positive direction is acting along the direction of the current flow. I4 is acting our default positive direction. So I4 is the positive current. So simplify this, 16, 4I4. So we have got the I4 and I4 is 4. So we have got I4 and that's 4. Now we have one left and that is this line, okay? So let's try to, okay, through this BG line. Let's erase this part. Okay, from B to G, this line, I2, okay. Let's take B, C, F, G, B, this loop. So that's our loop. We have to take CF common because it's resistance-less. How many cells do we have? We have 1 cell, 2 cells. We have 2 cells, so 2 EMF. Summation of E is equals to summation of IR. We need 2 EMF. So it's 4, so plus, minus. Okay. So the direction of this 4 is upward, right? Look, it's upward. So 4 minus. So now use this clock. Okay, use this clock. This clock is acting along the direction of 4, right? Clockwise direction, and the direction of 4 is same. So 4 is the positive cell. So now what about this 10? 10 is acting upward, and now this is the loop. So now let's move the clock, rotate the clock. The hand is acting, this 10 is not acting along the clockwise direction, it is opposite to the clock. So this 10 is now a negative cell. Okay, we're done with the left side. What about the right side? How many resistors do we have in this loop? B, C. So we have only one resistance, 6. And how many current is flowing through the 6? And this is I2, right? Okay, I2. So let's get I2. I2 is downward. Ahead, this is our I6 I2, okay? Just write it down. 6 I2. Resistance into current. So that's our hand, which is clockwise. So now you can see that, oh my god, this I2 is not acting along the direction of clock. So I2 through 6 is negative. Okay, so we don't have any other resistance, so only one. Simplify, this could be minus 6 and minus 6 I2. Doesn't matter why, I2 is negative, doesn't matter. So here, I2 is a negative current, but the value of I2 is now positive. So we have got positive I2. So now we have got all these three, these and these, by the use of the Kirchhoff's law. In each case, we have taken CF as common. Why? Because this line was resistanceless, is resistanceless. So now, there are another two lines, but fortunately the question doesn't give us, doesn't ask us to get the current flow through that lines. But we can get it through GF and BC line. How can we get it? How can we get it? Okay. So let's go through this current. So here I1 and I2 are moving downward. So this should be the current through GF. Let's assume it's I4. And also here from I2 and I1 is moving downward, so this will be this. Suppose this is I5. So I4 is the current through GF and I5 is the current through CD. Now I will use the junction because we already have three current. Okay, let's use junction B. Okay, from junction B, what we can get here? I2 and this line I1. So I1 is moving outward, I2 is moving outward. So I1 plus I2 outward current should be inward current, and only one current is inward, that's I5. So I've got I5. We know I1, we know I2, we can get I5, the current flow through BC. And what about use junction G? Okay, here I1 and I2 is moving inward, I1, I2 inward, I1 inward, I2 inward, and I4 is outward. So now, fortunately, look at these two equations. The left sides are same, which means the right side are same too. So though BC and GF are different line, but their current flows are same. We have got the current flow, so we can write I5 as I4. Now, if you want to get I3, it's quite easy. That's I4, right? This is I4. So through junction F, we can write I4 is inward. Oh my god, we have two I4s, that's the problem. So let's assume these I4. So we have this current and this current, so we can always get this current, right? So I3 will be summation of these two. These two are moving in and I3 is moving out. So we can easily get these I3. So I3 will be these I4 plus these I4. Okay? So we can get I3 2. So that is the solution of this question, this problem. It's a very interesting problem, and this problem appears in Dhaka College 2020 test exam. So I hope you understand these problems well, and if you have any problems, then you know the way to contact with me through the comment box. Please share this Kirchhoff's law, and when we will done with the Kirchhoff's law, I will upload a combined lecture regarding Kirchhoff's law later, and it will take another 2 days to complete the Kirchhoff's law. This is 11th lecture. 12 and 13 will be regarding Kirchhoff's law solution, multiple loop problems, and then we'll go through the Wheatstone bridge, and in Wheatstone bridge we'll again use the Kirchhoff's law. So that's the end of today's lecture. There will be a SW given at the end of this lecture. So please, this is my request for you all. As you are remaining at your home, it's better to remain at home, because the outside world is not well. It's not getting well. Each and every day the situation is getting worse. So please remain at your home, remain safe, and solve these problems. Watch these videos and solve problems. I'm exactly doing all this for you, and we will see another problem solutions in the next day. Till now, be safe, be happy, and be sound. Okay? Allah Hafiz. See you tomorrow.